Hi. Let's work through real quick rewriting the formulas for the right and left Riemann sums using summation notation. If you're curious where these formulas came from, check out one of the other videos. I've got this repeated expression f of, right? And it's just like I'm repeating myself a lot. And anytime I find myself repeating myself, I want to find another way to say it. And summation notation is the powerful tool that we use to rewrite this expression. So I want to rewrite r sub n as a sum over some stuff, and I've got a delta x. Okay, so the delta x is outside of my sigma because it's outside of the parens that indicate the stuff that I'm summing up. Okay, so the delta x is on the outside. And for clarity, I write it in front rather than behind, because that way I don't get confused on where the stuff inside the sigma ends. Otherwise, it would be more parentheses. So I think that the repeated expression is what goes here. So I've definitely got an f of. And it's also true that I'm repeating my x. What's the thing that's changing is this 1, 2, 3, 4, n minus 1, n. And so that's changing. I'm going to call that j. Just make up a name for it. Just call it j. I, j, and k are the common names for subscripts or indices. So if the variable that's changing is j, then I better have a j right there. And I say, where does it start? That's going to go here. And where does it end? That's what goes there. It starts at 1. And it goes to n. Pardon my stray mark. Okay? On the other hand, we can do that with left. L sub n is going to be equal to, all of them have a delta x in it. Delta x is outside of the parens for the things I'm summing up. So delta x, I've got a sum right there. I'm going to call it j again. Where do I start? I start at 0. And I go to n minus 1. What am I doing? What's my repeated action? I'm applying f to some x value. Which x value? The jth x value. So we can see really easily, and I think it's more apparent in the summation notation of writing down these two expressions, what the actual difference is. The only thing that's different between them is j equals 1 to n, j equals 0 to n minus 1. Whereas, like, when it's this big long string of symbols right here and everything's kind of mixed together, like, I feel like I have to really look to find the difference between the two expressions. Whereas when I use summation notation, it lifts the lower and upper bounds for the sum to strong prominence as the lower and upper elements of the summation notation. And I think that's one of the things that makes it most powerful. Okay, what's missing from this? These two formulas right here, they don't tell me what is x sub j, right? So I still need to go look up in a list somewhere. Something is telling me what the values for x sub j are. And of course, we haven't been told what f is yet, nor what delta x, but I feel like those two are pretty clear. Delta x is the width of a rectangle in uniform partition. And f right here is what we call the integrand, or the function that we're integrating. So when we have our axes, and I have my function that's doing whatever it's doing, I've got my function f right here as the integrand. So it is the thing that's determining the heights of the rectangles, and my x sub j's live down here, and they range from x0 on the left and x sub n on the right, and there are a total of n plus 1 of them. The right one omits the first. The left one, because it stops at n minus 1, omits the last, and that's the only difference between them. Okay, thank you so much, and wishing you all the best. Bye.